Learning to code by reading syntax is like building a house by staring at blueprints. You need to pick up the tools and start assembling. Today, we'll build a simple interest calculator. It takes financial inputs, calculates them, and returns an accurate sentence. We'll use 4 tools: variables for data types to classify it, arithmetic operators for math, and string formatting for the final answer. Once you understand how these tools interact, you can begin taking raw input from a user and processing it into a specific calculated result. Step 1 is asking the user for their name. We do this using Python's built-in input function, which opens a prompt in the terminal for the user to type into. But that text needs a place to live in the computer's memory, so we assign it to a variable. Think of a variable as a labeled container built to store the data we just captured. Python has strict rules for writing these labels. A valid variable name can only contain letters, numbers, and underscores. You also cannot use spaces or special symbols, and the name cannot start with a number. So student underscore name with an underscore is perfectly fine, but starting with a number like one name throws an immediate error. Nailing this naming syntax right out of the gate is critical. It prevents programmatic failures before we even get to the math. Next, we need to gather the actual numbers for our calculation: the principal amount, the duration and time, and the interest rate. If we just use the basic input function again, we hit a roadblock. Python automatically stores all user input as a text string, and you cannot do math on text. To fix this, we use explicit typecasting. This is a mandatory step that manually forces the captured text to convert into a usable decimal number. We use the float function, which handles decimals. Notice how it wraps directly around our input command. The text goes in and a numeric float comes out, but you have to be careful here. If a user types letters instead of numbers into a prompt that strictly expects a float, Python will trigger a value error and crash the program. Anticipating what your user might type and explicitly casting the data types to match your operations protects your software's logic from crashes caused by unexpected input. Now we execute the formula for simple interest: principal times time times rate divided by 100. To translate this into code, we swap standard multiplication signs for asterisks and use a / for division. Python follows standard mathematical order of operations. To ensure the multiplication resolves before the division occurs, we wrap the entire top half of the equation in parentheses. As you type this out, watch your capitalization. Python is strictly case-sensitive. If you define a lowercase p for principal, but use a capital P in the formula, you will trigger a name error, because the computer won't recognize the variable. A computer takes your instructions literally. Navigating case sensitivity and order of operations requires absolute precision in how you lay out the code. We have our final calculations stored in a variable. The last requirement is displaying that raw number back to the user, alongside some conversational text. The most efficient way to do this is with an F string. By placing a lowercase f right before our opening quotation mark, we inject variable data directly into the sentence. Inside that f string, we use curly brackets. These act as placeholders that tell Python to seamlessly drop in the captured name and the final calculated interest variable. To make the output look a bit cleaner in the terminal, we can also add a \n. This is an escape character that automatically forces a visual line break before printing the final sentence. Data is only useful if it's presented clearly. Adding context through formatting ensures that the person using your script sees a clear answer rather than a solitary, unexplained number. The code is written. Now we run the script in our environment to verify the logic holds up. We enter a test name, followed by numeric values for the principal balance, the time frame, and the interest rate, and the terminal returns our desired result: a cleanly formatted, dynamically generated sentence holding the precise interest calculation. We started by assigning variables, explicitly cast our data types to allow for math, processed the numbers through precise arithmetic operators, and packaged the final answer using f-strings. Now it's your turn. Take this exact same architecture and build a temperature converter. You have the fundamental